In section 2.1, we started talking about different ways we can gather data using histograms and relative frequency histograms and ogives. In this section, we're going to talk about a few other types of graphs: bar graphs, circle graphs, and time series graphs. So while histograms do help us provide a useful visual display of data, that data has to be quantitative. We can't use histograms for qualitative data. But there are other graphs that we can use qualitative data for. Starting with bar graphs. Like, we all know what bar graphs are. We've seen bar graphs before. Bar graphs are graphs that can be used to display quantitative or qualitative data. So a bar graph, bars can either be vertical or horizontal. Then they have the same width and they are spaced evenly. And the lengths of the bar represent values of the variable being displayed. That's your the frequency of occurrence or the percentage of occurrence. The same measurement scale is used for the length of each bar. The graph is also well annotated. It's got a title. It's got labels. It's got a vertical scale or actual value for the length of each bar. So, for example, here's two bar graphs depicting the life expectancies of men and women born in the designated year. So again, if you look at these two graphs, again, all the bars have the same width. They are both even, both pairs are evenly spaced. You have a title for your graph. You have the variable of the year of your birth. You have the measurement, the age, and your vertical scale. So, and all these are well annotated. But sometimes, you might need to change the scale of your graph. Sometimes whenever you use a change, you see a little squiggly line like this to show that change. Sometimes if a single bar is unusually long, the bar length is compressed with a squiggle inside of the bar itself. So for example, if we look back at the two graphs that we just saw, they're exactly the same, but they look different. Why is that? Well, look over here. In this graph right here, your age measurements are ranging from 0 to 100, and they look almost like both the men and the women don't have much of a difference. Here, you have the little squiggly line, so you're kind of jumping from 0 to 65, and then 65 all the way up to 85. And so usually when a little squiggly is introduced here, it's meant to emphasize differences between groups of people or groups of individuals in that study, where at first glance it wouldn't normally be that much different. It's like if you were looking at this graph from very far away and you walked closer, and this is what the graph actually looks like. Now, even though it doesn't look like they have much difference, the change in the scale helps emphasize some of that difference. It's all about perspective here. Okay. Another type of bar graph is called a Pareto chart. A Pareto chart is a bar graph in which the bar height represents the frequency of an event. In addition, the bars are arranged from left to right according to decreasing height. In other words, Pareto chart acts as like a frequency tool. You record the frequency of an event, and you start with the bar with your highest frequency, and you work your way down in decreasing order from largest to smallest. So here's an example of a Pareto chart. In the Aloha state, you are very unlikely to be murdered. It is considerably more likely that your house might be burgled, your car might be stolen, or you might get punched in the nose. The following numbers represent the crime rates per 100,000 population in Hawaii. So for every 100,000 people in Hawaii, you have 2.6 that are murdered, 33.4 that are raped, 93.3 that are robbed, 911.6 that are house burgled, 550.7 for motor vehicle theft, and 125.3 for assault. So we're going to organize this in a Pareto chart showing the crime rate for each category. Okay. So again, here's my data. I'm going to start with my highest one. That's always one you always want to start with. So here, that's number 1. The next one up is motor vehicle theft, which is number 2. Then assault, which is 3. Robbery, which is 4. Rape being 5. Murder being 6. Okay. So we're going to go ahead and organize this. So I'll start here. And notice I'm not labeling these by much, or I'm not quantifying the level with a y-axis. I'm just showing, in a proportional way, the differences between the six categories. So again, this first one is house burglary. Then next up, we're going to motor vehicle theft, which is a little more than half of this. So here's the halfway point. I'm going to give myself a little bit of space here. All right, and this is motor vehicle theft with, and I think I'm going to put the quantity at the top here, 911.6, 550.7. Next, I'm going to go assault. Assault is pretty much a fifth of this. So if I break this down, so 1, 2, 3, about right here. Let's say we'll put it right here. Now, I don't want to connect these like a histogram, so I'm going to actually erase these. Erase this little tick mark right here. All right, and that is number 3. That's assault. That's 125.3. Then we have robbery, which is just slightly less than that. So robbery at 93.3. Then we have rape, which is a third of that. So if I separate this, it's kind of more like this right here. And I'm going to go ahead and erase this part right here to kind of keep it even. And that's 33.4. And the last is murder, which is 2.6. So I'm going to make a very, very small bar graph right here. Murder, 2.6. And there's your Pareto chart. Okay. Again, it follows the same key qualities of a bar graph. The bars have somewhat uniform width. They're evenly spaced apart. It follows the characteristics of a Pareto chart, where your highest frequency is first, and you work your way down from largest to smallest frequency. Okay, that is a Pareto chart. Then we get to circle graphs and pie charts. Y'all know what pie charts are. Y'all have seen pie charts before. It's another popular pictorial representation of data. So when you work on circle graphs and pie charts, the total quantity is 100% and is represented by the entire circle. Each wedge of the circle represents a component part of that total, or a percentage, if you will. So here's a circle graph or a pie chart. In a circle graph or a pie chart, wedges of a circle visually display proportional parts of the population that share a common characteristic. So, for example, I want to find out how many siblings a group of people has. A group of people have, I should say. Let's say my sample size is my annotation tool. Let's say my sample size is 10 people. Let's say out of those 10 people, 5 of them have no siblings. 3 of them have 1 sibling. 2 have 2 siblings. And 3 have 3 or more. Oh wait, hold on, that's not right. Hold on 1 second here. We'll say that actually, mark this down too. We'll say 1 person has 1 sibling, 3 people have 2 siblings, 1 person has 3 or more siblings. Okay, that's a sample size of 10. So looking at this graph here, I'll start with 5. That's half of 10. So half of the circle, half the pie chart, is going to go towards no siblings. That leaves us the rest to divide out. Okay, so of this half, a majority of it is going to go to the 2 siblings. Okay, so this is 2.5. I'll go slightly up. So this is 2 siblings. That's 3. Okay, and so because they have the same frequency, I'm just going to split this in half. So 1 sibling and 3 plus siblings. Okay, so whatever proportion or whatever percentage of the pie chart your data point is from the sample, you want to make sure that it's reflected in your pie chart. And we'll have some practice where we look at how to create our own pie charts and how to properly do that using the measurements of the circle. Then you also have what's called a time series data. So data sets composed of similar measurements taken at regular intervals are called time series, and that's regular intervals over time. We use time series data often in economics, finance, sociology, medicine, and pretty much any situation where we want to measure a particular variable over a period of time. A time series graph can reveal some of those features. Time series data consists of measurements of the same variable for the same subject taken at regular intervals over a period of time. So here's an example. Suppose you begin an exercise program that involves walking or jogging for 30 minutes. You exercise several times a week, but monitor yourself by logging the distance you cover in 30 minutes each Saturday. In order to display this data, we'll use the time series graph. So in a time series graph, data are plotted in order of occurrence at regular intervals over a period of time. So for a time series graph, the x-axis is going to be our time, and our variable being measured is on the vertical scale, is on the y-axis. So in this example, if I'm doing this as an example, so each week that would be my x values. Week 1, week 2, week 3, and then my variable being measured would be logging the distance that I covered in that time. Okay, like for example, here's another example. Anna has been keeping track of her reading time each night for the past 2 weeks. Her reading times in minutes are given below. So here's your time series graph. Okay, you have all that data for 14 days. Okay, you have so again, we want to make sure that we know what exactly it is that we're measuring. My x-axis represents nights spent reading. So nights spent reading. Here, we'll mark this axis will mark the time we'll mark the time that we spend reading. So time spent reading in minutes. And we'll go ahead and make our intervals, right? So looks like they range from anywhere. They don't go higher. They don't go at 40. So we're going to mark these off every 10, 10, 20, 30, 40. Okay. And then for each day, we're going to mark where that number is. So for example, when x is 1, y is 20. So that's going to be my very first point right here. Oh, it's not a good point. Okay. Then we have 22, so just a little bit more for night 2. Night 3, we went down a little bit, so you have to go down a little bit here for night 3. Night 4, we're at 25, so halfway through. Night 5, 23, so just a little bit less than that. Night 6, 24, so I got to find an in-between point for here. Mark that right there. Night 7, 22, so right underneath 23. Now, it's not going to look completely perfect, but I'm going to try my best to make it look as accurate as possible. Number 8, 26. Right here. Number 9, 27, so just a little bit more here. And then same for number 10. Number 11, now we're really ramping up. 30, right here. 12, 29, so right just underneath that. Okay. Then for 13, it's 31, and 14 is 35. So 14 here, and then 35. We'll put that right here. So now we're just going to go ahead and connect these line segments. You want to make sure you make your, don't try to curve this. Don't try to curve this because you really want these values to be as distinct as possible. So we started out slow these first few days, but then towards the end we really ramped up. It could be that maybe the book that she was reading was really, really good and started to ramp up towards the end to the climax. It might be that she was just finishing up one book and then moving on to the next one. Who knows? But that's what time series graphs can help us explain. But how do I know which ones to use and when to use them? For bar graphs, you can use them for quantitative or qualitative data. With qualitative data, you have frequency or percentage of occurrence. But with quantitative data, you can actually use the measurement itself to display here. Pareto charts are better suited for frequency of events in decreasing order of frequency of occurrence. So if you wanted to put these in a particular order, a Pareto chart would probably be the easier one for you. Circle graphs display how a total is dispersed into several categories. So circle graphs are very categorically focused. It's very appropriate for qualitative data and is most effective when the number of categories is 10 or less. If you have more than 10 categories, you're going to have some really small pieces of your pie chart. And then, of course, just as we talked about, the time series graph are best used to display how data changes over time. And it's best if the units of time are consistent in a given graph. We're using the same units of measurement for time with each value. But for any graph, you should always do these things. You should always provide a title. What is it that I'm looking at? Label your x and y axis. What variable are you measuring? That's the stuff that's going to go on the y-axis. What are you using to measure? That's your x-axis. And identify the units of measurement. Please identify units of measurement when you label your axes.